In the longevity field right now, we have a signal to noise problem. There's a lot of people who are claiming to be experts who are spreading misinformation. And it's really hard for people who aren't experts to figure out what's real, who can I trust.
Good morning, Renee.
Good to see you, Melanie.
I also have my coffee.
Which is, that is just mean because I don't get to drink my matcha. And here you are.
Oh, would you like to? Do you need some matcha? By all means.
As I look over at our producer who says, no.
Well, it is.
For consistency purposes, I will be matcha free. But enjoy your coffee for the both of us.
Yes. Yeah. How are you doing?
I'm doing great. We're on I'm on day 2. You're on day 3 of our FMDs.
Yes, we are.
So just chugging along there. I'm energized.
Are you? I was like, is chug the right word? Because I just did a little IG story on this yesterday that I'm shocked at how easy it's been feeling for me this time. I mean, this is the first fast back from pregnancy, so I'm also carrying a little bit more weight. I have a little bit more to pull and draw from in terms of body fat. But either way, I'm like, even from the cravings perspective, I'm cruising.
I love it. Okay, wait, but that totally aside, does chugging along to you mean
grinding? It felt negative. Felt
okay.
like,
so for me, chugging along, it's like we're chugging along.
Oh, okay.
You know,
I would say good. Like it's smooth. Yeah, it's easy. Literature, English language.
I just think of like a train, just like going down the tracks. It's good.
They're also
I don't know.
Loud and mechanical. Anyways,
but we're both doing well, is what I'm hearing.
We're doing well. My energy's up. I don't have a lot of cravings. Yeah, I knock on wood. Day 3 tends to be kind of hard for people, but I'm doing good.
Autophagy is on.
Yeah. Yes. The Nobel Prize winning discovery is happening in my body at the very moment.
Yes. Which we talked about in this episode too.
Yes, we did. Yes, we did. Oh gosh, Matt Kaeberlein. What a brain. What a brain. My God. Very excited to share this episode.
I feel like we say this a lot, like, oh, I could sit with this person and talk all day. But which is true for like all of our guests, yes. But especially true with Matt. He was just
because I want to know everything he knows.
And he knows so much. It's like we'd be here for years.
Stay tuned. Great episode upcoming for you guys. But before we do that, let's dive into our myth or method today.
Yes.
Would you like me to tee us in?
Tee us in? Okay. Yes, give it to me, baby.
So our myth or method today is about detox foot pads and castor oil packs, which when I first read our myth or method, I was like, those are very different.
That's so funny. Yes. I thought the same thing.
I was like, those are entirely different things.
So let's split them up.
Yes, because they need to be split up.
Okay.
So, well, first of all, the question is, the concept that we're debating is, are adhesive foot pads worn overnight or castor oil packs on the belly, which we're going to differentiate, draw toxins out of the body? Mm-hmm. The proof of the pad turning brown in the morning has a lot of people thinking, oh my gosh, look at all the toxins. I think I veer more in the functional nutrition side of things. I do a lot of alternative modalities and healing to help amplify my work with patients, and those are not the same. They're not the same.
I knew you would do that. I knew you would say that. I agree.
Oh, thank goodness.
I agree, but for very likely different reasons.
Okay. So launch us off.
I'm going to launch us off because I think mine is going to be short and sweet.
Okay.
Research on the foot pads, negative. Like there is that it's not even a thing. In fact, the brand that was doing this like back in the early 2000s got sued by the FTC for false marketing. There's nothing there.
The data is nil.
Right. And for the pads of the foot turning brown, we know that is just oxidation, and that's just what happens. Like literally you just put water
water.
And it would turn brown or black, right? So you don't it's just your foot sweating onto it, which it does whether you have that foot pad or not. Mm-hmm. You're not getting any of that detox. So that's an obvious no. For the castor oil, also very limited research. Yes. Now, at least with castor oil, there is some research on the ingestion of castor oil as a laxative.
Topical use too, like for hair, skin.
Sure. Yeah. Although, in terms of the detox and the belly button, also research very limited. So because of that, I'm going myth across the board. I do think that with the belly patches, there is some very likely just other things that are happening. Like oftentimes people are putting on a heating pad or they're massaging it or they're doing all these other things. They're laying down for an extra little while of time. All of those things we do know are associated with better outcomes and healthier and longevity and healthy aging. So I would say it's a myth.
From the detox perspective, you're calling myth. It is the short answer. Foot pads, no. Yeah. Wrong. Not going to do anything. Castor oil is really interesting for me. So first of all, castor oil is very moisturizing. There have been some anecdotal evidence to showcase its benefit on for skin health and hair growth and all of that type of thing. And decently, I would say the downsides of using that are very minimal. So, safe thing to try in that way. As far as the detox perspective, as a gut health practitioner myself, you nailed it though. When you use castor oil packs, you're putting castor oil on a particular part of your belly where your small intestine is, your large intestine is, your stomach is, wherever your digestive ailment lies. You then lay another layer of whether that be cotton pad or something on top of it. And generally it works best when you put heat on it. And usually because of the state of laying down, relaxing, you're activating the parasympathetic system of the body. We know that there can be digestive ailments that are made worse and or even have a root cause in elevated stress, having a lot of inflammation. So when you have heat put in basically castor oil, when we talk a lot about like acupressure points and other modalities like this that aren't as well studied, you really are telling the body, we are focusing right here and you're bringing energy into that space. Yeah. And that can be do I think that you are pulling toxins out through the skin in that way? No. Mm-hmm. Do I think that you are giving the body signals to, hey, we are focusing here. Are you relaxing? And that's helping to give your body signals to then help ignite the systems in the body that support that 100%.
Right. But I would argue if you threw this in a randomized clinical trial and you had one group doing castor oil and another group doing olive oil, they would come out the exact same. That's my theory.
That's your theory.
It is my theory. It has obviously never been tested, but I think that it is more so the other things as opposed to the castor oil. Yeah. So
well, that's what we know now. That's what we know now. I still think it is the risks of doing a castor oil pack are minimal. The rituals of it, I think, are wonderful. And I also, agree with that. And I have seen a lot of, and again, whether it be from the castor oil itself from the detox or from the other heat relaxation elements, we can't say for certain, but I do know that especially for my patients who have constipation dominance. So I would say these are not the same thing. Although if you are interested in the foot pad, go soak your feet in hot salt water. Like your skin is highly it is the place in your body where you detox. Organ, so getting your body to pull things out. So getting into a bath is a better, like a salt
and
bath.
A scrub, a good scrub too in like your armpits and all in those regions.
Getting your lymphatic drainage going. Though all of those things I think can be highly useful when you are on a protocol for something that you are trying to detoxify. They can be helpful to moving things along, whether there's scientific eventual evidence to prove the actual detoxification. We can't say for certain. So 3, 2, 1, myth. Myth for the foot pads. Method. Conditionally method for the castor oil, depending on how you're using it.
I'm going myth and myth, but it's fine.
Okay. All right.
Well, we have an incredible episode coming up, as we have hinted at more than once. It is coming at you right around the corner.
Yeah, stay tuned. Welcome to the show, Matt. We have Matt Kaeberlein here, who is honestly one of the leading longevity scientists that exists today. You have over 250 longevity-related research articles under your belt. You are a biologist, a gerobiologist, and you have, right? You're an incredible aging scientist and a very science-backed and science-led. You led one of the coolest studies called the Dog Aging Project, where you actually researched rapamycin in dogs and have been using that research to help inform some of our aging. You're the founder of OptiSpan. You just launched your own podcast, Longevity Science, with Matt Kaeberlein, I think recently too. So
the list goes on.
Yes. Oh my gosh, it's a 2-page bio, but Renee and I, as longevity dietitians, could not be more giddy about having you on our show today.
Yeah, we're gonna nerd out a little bit.
I'm looking forward to it. Thank you so much for inviting me down.
Oh my gosh, of course.
Okay, so to kick things off, we ask everybody the same first question, which is, what is the longevity hill that you will die on? AKA, what is the one thing that you think everybody should know that they don't really know?
I would reframe it. The one hill that I will die on and that I have sort of gotten a reputation for this is I feel like in the longevity field right now, we have a signal to noise problem, and there's a lot of noise out there. And I think when it comes to the science of longevity, we need to be precise in the way we speak as scientists, and we need to tell people the truth. And that means both presenting the truth about where the science is at right now, but also calling out misinformation. So I think this is, if I had to pick one problem in the field, that would be the problem that I see, is there's a lot of people who are claiming to be experts who are spreading misinformation, and it's really hard for people who aren't experts to figure out what's real, who can I trust. And so that's what I try to do, and I try to be honest in giving people a feel for, what's really well established, what's got science behind it, but is perhaps a little bit questionable right now, and what is non-scientific. So that's the hill I would die on.
Yeah, and we're going to peel all of those apart. We're going to try and figure out where everything goes in your buckets.
Can I really quickly I think that this is mega important because longevity has, obviously the word has been around forever, but it has really blown up in the last 2-3 years especially, I feel like. And I think it's become everything and nothing depending on who you talk to.
100%.
If you're talking to a
calling it longevity
company,
washing now.
Yes.
Because you're just like, anything is longevity.
Yeah.
Everything is longevity.
If you're a supplement, you're going to say it's an NAD that's going to keep you alive forever, well forever. If you're into cold plunging, whatever it is. So I really think you're speaking near and dear to my heart. That's a huge longevity hill.
Yeah,
that's a huge longevity hill.
And I watched your recent episode on Is Rapamycin Dead?
Yeah.
And you kicked it off just by saying, listen, this is one of the biggest problems is that there's so many people out there that are just spouting things that are just maybe their own personal experiences or not founded in science. And it's impacting your research that you've spent decades doing.
Yeah, and I think, part of this is that because the word longevity is new, so many people who, 2 or 3 years ago would have characterized themselves as wellness have just sort of co-opted that term. Mm-hmm. So it's happened in the wellness space. And in the medical space, it's the same thing has happened. People who 5 years ago called themselves functional medicine now call themselves longevity medicine. Mm-hmm. So like you're saying, the word means everything and nothing, depending on who you're talking to. And so you get a lot of different opinions, and that's okay. Like, I think it's fine for people to have different viewpoints, different opinions. The problem that I'm trying to address is when people are presenting information as fact, as science-backed, really helping people to evaluate, is it? Like, what do we actually know?
Yes.
So what do you recommend in today's world, you're going through your social media, you see one thing after the next. How do you pick apart what is legit and what is not?
I don't have an easy solution. I think this is part of the problem, right? Because the people who have millions of followers on social media and call themselves longevity experts, number one, aren't. So I think one thing I would say is look at the person and ask yourself, what is their actual background and expertise? How many of these people have actually been in the field for a period of time? Have they ever contributed anything to the field? Mm-hmm. Or are they just a talking head, right? And I think if you do that, and again, different people can have different opinions. Maybe you don't value expertise. That's fine. If that's the person you want to follow, that's great. If it's entertainment, that's fine. But you should recognize if they don't actually have demonstrated expertise have never contributed something to the field, the likelihood that they're actually going to know what they're talking about is pretty low. So if you value evidence and data and science, then you probably want to get your information from somebody who actually has the experience and the expertise.
Right.
And there are a couple other warning signs that I look for. One is if people talk with 100% certainty, like you talked about NAD. Take the NAD booster and it will make you live longer.
That's it.
There is very little in longevity that is 100% certain.
Yeah.
There are things that we feel pretty confident about, but that's a red flag. People who talk with 100% certainty. The other thing that and this just sort of blows my mind, like my view is if somebody lies to you once, they're going to lie to you again. And the fact that people continue to follow these influencers who have been caught lying multiple times just sort of blows my mind. So again, if you value honesty and data and scientific rigor, don't believe people who are demonstrated liars. Like, it's pretty simple.
Yeah. I do think the really cool part to me, this exact moment in our longevity experience as a society, is that I am already seeing the shift from influencers, non-credentialed influencers being sought after to actually some of these conferences and entities actually creating science boards for longevity. So the shift is, let's get some science, let's get some experts in the field to participate.
So I was just at Aspen Ideas Health, and they did some research on this. 6 out of 10 influencers in the health and wellness space have 0 credentials.
Yeah.
6 out of 10.
I believe that. And then I would add on another 3 out of 10 have credentials, meaning they might have an MD or a PhD in a completely unrelated field, right?
Yeah.
So,
That's true.
So that doesn't surprise me.
Yeah. And are now
true.
labeling themselves as longevity or whatever.
Right.
Yeah.
But this is why you're sitting across the table from us today, because you are not one of those shams. You, with the 250 research publications that you have in your belt, I mean, you really understand this space. Well, maybe, we obviously are big Walter Longo fans, but
I'm a Walter Longo fan too.
Right.
So.
But you're like right up there with them, like there are a handful of longevity researchers that are like the top of this field, and you are one of them. So we're grateful to have you here. And so we need to pick your brain.
Sure.
And we need to know what we need to know.
We need to know what we need to know. Can we start? I mean, I think that your dog aging project is huge, and it's still something that people are. I mean, are you still doing work on? Okay, it's still ongoing. Okay, can you give us some insight into why you opted? Well, first of all, we want to know about rapamycin.
Sure.
And we also want to understand, why have you made the shift to researching this in dogs versus typically when we do preclinical work, we're doing preclinical work in rats or mice or what have you. So
yeah, great question. I'll give a little bit of the origin story because I think kind of frames why dog aging project. So I actually started in the field as a graduate student in 1997, studying the genetics of longevity in yeast.
We're all doing the math right now.
I know, right? How old is Matt?
How old is he?
55. I'll make it easy for you. So I was working in yeast, and then as a postdoc, I started using C. elegans, which is a nematode worm, and doing studies in mice. So I did that foundational work in the laboratory animals. And I've always been a dog person. I've had dogs my entire life. And
which makes you an awesome human. Anybody who's a dog person.
I tend to feel the same way, but you could be a cat person and be an awesome human too.
Yeah, that's true. As long as you're also a dog person.
Yeah, right. I am not going to say that. That sounds way too controversial for me. So I in I think it was 2013, 2014, was co-directing a summer course at Woods Hole that the Ellison Medical Foundation put on for biology of aging. And it was a super cool course where there would be 2 directors and we would bring in like 20 people to give lectures, and there would be 20 students who were graduate students, postdocs, even sometimes like journalists would come because they were really interested in longevity. And it's very intensive, like 3 weeks, not 24/7, but you're there every day. You're really, talking to these people a lot. And so Daniel Promislow was the co-director of the course. And Daniel had been thinking about observational studies in dogs with respect to aging because, of course, dogs age 7 to 10 times faster biologically than people do. And so the value there is you can follow dogs for 10 years, and it's like 70 years in people of information about aging that you can learn. It's most of their life. So I thought that was cool. Again, as a dog person, obviously recognized how valuable that could be. But through talking to Daniel at this course, I had this light bulb moment that I still, to this day vividly remember, where, I'm thinking about dogs and I'm like, in my lab, we're studying rapamycin and caloric restriction and, interventions that slow aging in mice. Some of those things are going to work in dogs. And I literally to myself, I thought, oh my God, we could slow aging in dogs. And then I thought, oh my God, we could slow aging in my dog. So I'm like, huge. I have to do this. Yeah, no, it was really like 30 seconds going from, dogs, it makes sense. It'd be cool just do a study in dogs to I have to do this.
Right.
And so then I said that, and that was sort of a shift in trajectory where I'm like, okay, what does it take to actually make this happen? And so started thinking about how would you design a clinical trial? What would you test? The two leading candidates at that time were caloric restriction and rapamycin. They still are, in my view, and we could talk about why. Yeah. But for a study in pet dogs, and again, I was not going to do this in dogs in a kennel in the laboratory. This, in my view, needed to be in companion dogs. So for a study in pet dogs, trying to get owners to calorically restrict their dogs seemed like a pretty heavy lift to me.
Yeah.
So rapamycin was sort of the default if it could be done safely. So that was like number one, could we actually do this safely? Number two, could we get money to do it, right? And so I set out trying to raise money to support this clinical trial. And, it took a while to actually be able to do that, but we were able to start the first clinical trial. I think it was probably 2015 with a fairly small budget. And sort of around that time, we were getting some media attention because I had talked to a Nature News reporter about this idea. She got super excited. She printed a story on it. Then it got picked up by, I think, the UK Guardian and by the Seattle Times. And so we knew this Seattle Times story was going to come out. And my wife and I are sort of talking about it, and we're like, well, the story's going to come out. We need to create some way for people to register interest in the clinical trial, right? And she's like, well, I can make a website for you. And, it's like Friday and the story's coming out on Monday. And I'm like, oh, that'd be great.
We love our partners, our multimedia partners.
We could create a form and people can, can indicate that they want to participate. And she's like, what should we call this thing? And I'm like, well, I don't know, it's aging and it's dogs. Let's call it the Dog Aging Project. So that's how the project came about. Yeah.
So creative.
Yeah. And so, but it really, and so we did this short-term clinical trial for 10 weeks in 2015 and we did another one, but we didn't really get the momentum until 2018 when we got the first NIH grant. And that's amazing. For this much larger project that the Dog Aging Project is today with Daniel, who I mentioned, and Kate Creevy, who's our chief veterinary officer and also a co-founder of the project. So the bulk of the Dog Aging Project is really this observational piece that Daniel and Katie had been thinking about, even before I came on the scene. And there's like 55,000 dogs now and owners around the United States participating in that.
And it has to be, just to be super clear, you made the very clear decision to make it companion dogs because they share your environment the closest, right?
Also, as a dog person, I'm just personally not comfortable with research on captive dogs.
Okay.
But yes, there is that piece. I mean, that's one of the reasons why dogs are so powerful in this way is because they share pretty much every aspect of the human environment, with the exception of diet. Most people don't feed their dog the same food they eat. But outside of that, some do.
What about genetically? Like, how similar are they to us?
I don't know what the percent is, but it's 98% or something. Wow. I mean, they're very genetically similar. But this is true even across all mammals. I mean, like the amount of the genome that's shared is very similar. I think there's a couple things to say about the genetics of dogs that also make them a powerful animal in which to study aging. One is, it's pretty clear that the biology of aging is highly shared between dogs and humans. The same functional declines, the same diseases happen with age in dogs that happen with age in people. So that biology seems to be very, very highly conserved. And dogs have this unique, as a population, genetic architecture. So we have a couple hundred purebred breeds of dogs, the common breeds we're all familiar with, and then less common breeds. But those are almost like inbred mouse strains because there is this inbreeding component to make them purebred, right? But on top of that, we have the mixed breed population, right? And so that architecture creates a lot of power for mapping traits onto genotype, right? Genetics. Yeah. And so that's something that in some ways is even superior to trying to do that in humans because you have that combination of purebred and breeds that get specific conditions at a higher prevalence because they're inbred and the mixed breed population.
Right.
Super cool. I mean, but I need to know, what do we figured out so far, and what is there still to learn?
Yeah, there's a lot more to learn than what we know. And I think that's true in longevity too. We might want to come back to this because I think there's this
100%.
myth that we've sort of figured out aging biology.
Oh God, no. Yeah.
We're scratching the surface.
Yeah.
Yes.
Yeah. So there have been probably 100 or so papers published from the Dog Aging Project since we started. And again, I would bucket it differently. So we could talk a little bit about what we learned about rapamycin. But from the observational study, those papers have been in a variety of areas. So there's been papers on nutrition and diet. There have been papers on exercise, papers on dementia, papers on environment. So like, contaminants in well water, pollution, and even some studies on like social, how does the socioeconomic status of the owner impact the health of the dogs? So it spans a pretty wide spectrum. And so to give people a flavor for, the kind of data that we collect, the way the Dog Aging Project works is people go to the website, dogagingproject.org, and it's still active. So anybody who's got a dog, any age, any breed, we want puppies too, can still participate in the study.
I have so many people I'm going to be sending this to. I'm so excited.
So the owners go to the website, dogagingproject.org, and you click Nominate My Dog, and then you're asked to complete what we call the Health and Life Experiences Survey. That's our primary data collection tool, and it's pretty extensive. It takes 2 hours sometimes, 10 modules. You don't have to do it all at the same time, but that asks questions about the dog's health history, the dog's home environment, what the dog eats, how active it is. We try to collect as much information as we can about the animal and the environment that it lives in. And once people complete that, they become members of the Dog Aging Project PAC. So that's the 55,000 or so that I mentioned.
PAC.
Yeah.
I love it.
And you get a certificate with your dog's name and your PAC number and all of that. And then you're asked to provide a qualifying veterinary medical record. Usually that's a PDF you get from your vet. People who do that become eligible for what we call the sampled cohorts. So we have genome sequences, I think, on 10,000 dogs. And then there are 1,000 dogs that are participating in what we call, it's like a systems biology cohort, where every year we ship a kit to them. They take that to their vet when they go in for their annual visit to collect blood, urine, feces, and hair. And then we do all sorts of molecular analyses on those with the idea of trying to identify biomarkers that are correlated with health outcomes in the future in those dogs.
This is the best research. Yeah. This is the best.
Also, just getting to spend time with dogs all the time and find out about, it's like a dream combo.
I feel so grateful to have gone down this path and been involved in this research. Because like you said, for somebody who's a dog person, it doesn't get any better. And I look back and I'm like, it sort of surprises me that it took so long for me to connect those two dots. Because, I've always been a dog person. I love dogs. I love my dogs. And, I've been working in the longevity field for 20 years at that point, almost. So it took a while to connect those two things, but I'm glad that happened. Yeah.
In the project?
Yeah, so all of my dogs have been in the project. Daniel, Katie, and I made the decision early on that we would not have any of our dogs in the sampled cohorts or in the clinical trial because those are supported by NIH funds, and we just didn't. We wanted to keep that separation from the NIH grant supporting our personal companion animals.
Yeah, that's fair and very scientific of you.
I know, right?
I do wonder if part of the struggle to make that link between doing this in dogs is partially because we are so in love with our dogs, we don't want to hurt them in any sort of way, which you kind of alluded to, that you wanted to make sure that this project was going to be as safe as possible for the animals.
Well, that's true for the clinical trial piece. For the observational piece, we don't ask the owners to do anything different than what they normally do.
Okay,
we have to ask, what was the inspiration for the dog project?
My dog. Yeah. So, so this is, I will try not to tear up. We lost our German Shepherd. It's been a year and a half, but still hits me hard. That's the most profound grief I have ever felt in my life. So he was the inspiration for the project, though. He was probably 3 years old at that point. And so when I had this, and we had two dogs at the time, but I don't know how many dogs you've had. I've had a bunch. I've loved them all, but I've had two dogs in my life that were just special, and he was one of them. So
we need a name.
Dobby.
Dobby.
Yes.
Dobby.
From
Only
named
3
after the house elf from Harry Potter. Yes,
course.
because when he was a puppy, that's what his ears reminded me of. Yeah.
Oh my gosh. I don't.
Sweetheart.
I have had a couple friends recently who've had their pets pass away, and I don't think people unless you're in it and have had this experience, I don't think people really truly understand the grief that comes with they're with you all the time.
Yeah.
They're with you more than probably any other human.
And they deeply understand you.
Yes, I know.
Yeah. Yeah, 100%. And I mean, like I said, I've lost dogs before, and it was always hard. But it was different.
What made it different?
Well, certainly the depth of the grief. I mean, like I said, he was just special. And again, I certainly wouldn't equate it to losing a child. Like, I think that's that's fundamentally different, a human child.
Yeah.
But it's not that far away in some ways. So
some might call him potentially your Damon. He's the animal version of you.
Yeah. Well, and it's interesting because this is a little bit off topic, but I went through sort of like, have you ever done these leadership trainings where they analyze your personality and tell you what kind of personality you are? And the coach who was doing that for us is like, your personality is a German Shepherd. And it is true. Like, I mean, I think, again, obviously that's a little bit of a simplification, but I am definitely, I have some traits that I would say align with. No, I'm not going to say that. No, but I'm like, I am probably loyal to a fault.
Yes.
I tend to be pretty skeptical of new things and new people. But once you have my loyalty, I will defend you with every ounce
They're
that I have.
they can be highly trained, which is
very intelligent.
You'd have to ask my wife whether I'm highly trained or not.
But very intelligent, we know that.
Well, that's the point.
Very
That's the point.
So Dobby was the inspiration, and when I had that moment of, oh my God, I could slow aging my dog, that's who I was thinking of.
Yes. Aw,
And so he had already passed at this point.
No, he was 3 when we started the project, or so.
Amazing.
Yeah, and we just lost him, like I said, about a year and a half ago. But I mean, and it's been tough. This is the longest I've ever gone in my life without having a dog, because we just aren't ready yet. Yeah, we just aren't ready yet. We're getting clear. We're getting there. We're talking about it, but we haven't done it yet.
That's tough. I mean, he'll never be replaced. That's what we know for sure.
No. Okay, let's talk about rapamycin, what it is, why you chose. Obviously, you talked a little bit about rapamycin and caloric restriction as 2 very pinnacle pieces of longevity. Why did you choose rapamycin?
Sure.
What is it? And how is it being utilized in this study?
Rapamycin is a small molecule drug. It was actually first identified from soil samples on Easter Island. That's where the drug gets its name. So Easter Island is also called Rapa Nui, rapamycin. So it's produced by a bacteria found in the soil on Easter Island. It was brought back to Canada and the United States and studied initially as an anti-cancer drug, ended up becoming FDA approved for organ transplant rejection. And basically what rapamycin, and that was 20 plus years ago. So we've got a lot of information on human use of rapamycin in the context of organ transplant rejection. We can come back to this. That's it's a little bit of a double-edged sword because it was first approved for organ transplant. It's thought of as an immunosuppressant. It's been used at very high doses in people who needed an organ transplant who are taking other strong medications. So in that context, there are some side effects associated with rapamycin, and that's what medical professionals think about if they know anything about rapamycin. So let's just table that for now, but we can come back to that.
Yeah.
In, 2023 or so, 4 different labs, and I was fortunate to be one of them, sort of independently stumbled on rapamycin and the protein that rapamycin inhibits, which is called mTOR, as important for longevity. So mTOR stands for mechanistic target of rapamycin. Okay. So 4 labs independently in 3 different organisms identified mTOR as sort of a central regulator of longevity. This was 2003 to 2005 or so. And so what mTOR does is it's kind of a central regulator of growth and reproduction. And so the way I like to describe this is if you think back through evolutionary time. And again, remember the goal of evolution by natural selection is to pass your genes on to the next generation. That's it. That's what you need to do. And when you do that, your offspring need to be successful because they need to pass their genes on. So that's the goal. Every organism that has ever existed has to make this fundamental choice, sense the environment, and decide, is it a good time to have babies? Because if you make a bad decision there, you're not going to make it in natural selection, right? Because your babies aren't going to survive. So if you think about what in the environment helps determine whether it's a good time to have babies, it's a pretty small number of key factors. How much food is around? Is the temperature right? And if you're an oxygen consuming organism, is there enough oxygen around? And mTOR senses all of those and kind of helps the cell or the organism make that decision. And it's most recognized as a nutrient sensor, but it does sense some of these other things in the environment. And so when there's lots of food around, mTOR activity gets turned up. So you can think of it like a volume knob, and that promotes growth and reproduction. When there's not very much food around, or when the environment is otherwise unfavorable, mTOR gets turned down. That shuts down growth and reproduction and creates a stress-resistant state. And as a byproduct of that, a slower aging state. Right. So what we and 3 other groups all observed was that when we turned mTOR down genetically, and this was in yeast, in nematode worms, and in fruit flies, aging slowed, they lived longer, they maintained function later into life. And then I think, at that time, we were all excited. The yeast and worm and fly guys were all excited. The mouse guys were kind of like, it's invertebrates, that doesn't matter. But I think people really started to pay attention when the interventions testing program showed in 2009 that you could give rapamycin to mice and extend their lifespan. And not only that, you could give it to old mice. So in that study, the mice were 20 months of age, which is about 65-year-old human equivalent. They started the treatment with rapamycin then and got a lifespan extension. And then since then, I know dozens of labs have shown repeatedly you can extend lifespan in mice. You can start the treatment young. You can start the treatment old. You can give the rapamycin for 3 months. So get lifespan extension, and you can improve function in pretty much every tissue and organ where it's been studied in mice. And in at least, I think now 5 different parts of the body, you can actually start the treatment after there's been an age-related decline in function and restore function. Wow. So this is true in the brain, it's true in the immune system, it's true in the oral cavity, it's true in the heart. So it seems like a pretty promising candidate from a preclinical. I think the only nuance I might add to that is because people get confused about this, because you also need to grow in order to, you need to build muscle and things like that. Right. So you want this, that's why I like to think of it as a volume knob, not an on-off switch, right? And mTOR activity is going up and down every day, right? And so I think what we see with age is there's a dysregulation of mTOR activity towards this growth promoting state. And so that's why giving rapamycin kind of turns it down, promotes that repair, renewal, and stress resistance, and increases lifespan.
Okay, so I have so many follow-up questions.
Well, it's all Renee always has so many questions. She's the
so maybe just to before we move on to say that was sort of the rationale in 2013, 2014 when I was thinking about if we're going to test something in dogs, what's the best candidate? Because there are other things in the literature that have been reported to extend lifespan in invertebrates, fewer in mice, although now we have more because the interventions testing program has been going for several years. But at that time, and again, I would argue still today, when you look at the magnitude of effect from rapamycin in terms of like % increase in lifespan or absolute increase in lifespan, and the fact that it seems to delay or even in some cases reverse functional declines of aging across the entire body, and the fact that it's FDA approved, it was sort of like the obvious choice if you can only test one thing and you're going to do a clinical trial in dogs.
Yeah. Well, the other thing before you jump in, because I know you have a million amazing questions, she really does. I think it's important to just reiterate that mTOR, amongst a couple other nutrient sensors, they actually sense nutrients. And in our day and age, in our society, in which there is a plethora of food and a lot of proteins and carbohydrates available, we are regularly triggering this way more than we used to in our early human ancestor days. Like we are in a state of constantly being fed. So when we are decreasing that in our current society at the right times in our lives, like not always, right? Like talked about the volume knob, it can be incredibly beneficial to us.
And I guess to jump off from that, one of my questions is in that volume knob is, how often should we be tampering mTOR versus not? There's obviously this very healthy balance that we have to find, and rapamycin is coming in and it's tampering it. It's saying, shh.
Right.
So how often can we do that?
Right. So I think this is where we have to be clear what we know from animal studies in the lab and what we think that might mean for humans, right? So in the mouse studies in the lab, I sort of alluded to this before, it seems as though there's a pretty big range of dose and timing you can use with rapamycin and still get longevity benefits. So again, you can start when they're young, you can start when they're old. My lab did a study where the mice were treated from 20 to 23 months of age with a pretty high dose of rapamycin, and we got a very large effect on remaining life expectancy. So it seems like there's many ways you can do it. We don't know what the optimum is, even in mice. Okay, so that's number one. In people, I think, again, we want to be careful. And this is where I think talking about caloric restriction might be useful. So caloric restriction is even better than rapamycin in mice in terms of magnitude of lifespan effect. It's about double the size. Wow. In fact, most people don't realize this. If we take out the genetic models where you make like dwarf mice, and because that's a different situation. So they go through development with low signaling and they're very small and they would never survive in the wild. So you take that out, caloric restriction is by far has the largest effect on lifespan in mice. And it's about double the effect you get from rapamycin. Rapamycin is number 2. Okay. So that's great, but there are good reasons to think that caloric restriction in people may not actually, certainly I would argue, is unlikely to have that magnitude of lifespan effect and might actually be detrimental because mice in the laboratory don't typically die from falls. They don't typically die from fractures. They get frail, but not the same way that people do. And they're in a protected environment where their immune system isn't constantly having to battle pathogens, right? We know in people, caloric restriction is, at least a severe caloric restriction, is going to exacerbate bone loss, muscle loss, probably attenuate immune function. So there's at least a pretty good chance you would actually shorten your lifespan if you did the same kind of caloric restriction in humans.
Particularly extensively,
chronic,
yes.
Yeah.
We're
That's what I mean.
talking about chronic
100%.
caloric restriction.
To give you an idea, the largest effect on lifespan in mice, as far as I know from caloric restriction ever published, was by Rick Weindrich and Roy Walford. They did a dose response. So the mice fed as much as they want. That's called ad libitum, right? That's kind of where most people live. So they did 10%, 20%, 30%, all the way down to 60% restriction. They got the biggest effect at 60% caloric restriction, which is probably like, 800 calories a day for a human.
Yes.
That's crazy. Yeah.
That's through most of their life. So again, just, that level of caloric restriction probably is not consistent with longevity in people and almost certainly is not going to improve quality of life.
Yes. Right. No, I can't imagine eating 800 calories every day for the rest of my life.
Oh my gosh, no, you talk about joy just being gone out the window.
But also this is where I think your rapamycin question, we can tie into that is I think in humans, you really, especially as you get older, you need a balance between anabolic processes, so muscle growth, maintaining bone density, things like that, and then turning down those anabolic processes at the right time in order to allow for repair and blunting of inflammation, right? So that's where rapamycin seems. So the answer is I can't answer your question because I don't know, right? We just don't know what the best way to use rapamycin is in humans.
Likely cycled? I'm just thinking in terms of fasting, mimicking. We say do 5 days, 3 times a year.
I don't have a strong opinion whether cycling is better than continuous for what I'm going to phrase off-label use of rapamycin. So and that word means prescribed by a physician, and it's called off-label because it's not the FDA indicated label use. Right. So anytime a physician prescribes an FDA approved drug for something other than what it's approved for, that's called off-label. Yeah. And that's allowed. So there are doctors who prescribe rapamycin off-label. Most people using rapamycin off-label do continuous, but some people cycle. And I just don't have enough data to know for sure. So what I would say though is there clearly is going to be a point at which if you take too much rapamycin, you're gonna bring down mTOR to a level where it becomes detrimental. And I think organ transplant doses are kind of right at that. I'm guessing a little bit, but they're kind of right at that level where you start to see some side effects that suggest this may be too much if your goal is to use rapamycin to promote health span, potentially increase lifespan. And when we were designing the dog trial, that's what we were kind of thinking about is, we want to find a dose where we're confident it's not going to cause significant side effects, but where it hopefully will be enough that we can see benefits in terms of lifespan and health span metrics. The other thing that's probably worth saying, this is a little bit in the weeds, but cycling means different things to different people.
Right.
So in humans using rapamycin off-label, most people are taking it once a week. Organ transplant patients take it daily.
Okay.
Multiple milligrams a day for organ transplant patients. People using it off-label for, we'll just call health span purposes, usually take 6 milligrams a week, but there's lots of variation around that. I don't think of that as, that's not what I mean when I say cycling, even though it is a once weekly cycle. What I mean when I think about cycling is you might do that 6 milligrams a week for 3 months, and then you take 3 months off.
That's my instinct as, especially, in the peptide world and everything. We're hearing a lot about this cycling and just giving your body a break from, whatever. Even with supplementation, by the way, there's a lot of that happening too. And so, I don't know. Very unscientific approach, but it's just like that's my gut instinct.
Well, with rapamycin, I think the rationale that I gravitate towards, if you're going to do, say, 3 months on, 3 months off, is probably the biggest effect that rapamycin has on health span in people is blunting chronic inflammation, right? It just seems to be very effective at doing that.
Right.
And we know that with age, almost everybody gets an increase in chronic inflammation, and chronic inflammation contributes to, if not causes, many age-related diseases and functional declines. And fasting does the same thing, by the way. If you can take rapamycin, bring down the chronic inflammation, say that takes 3 months, it's going to take a while for those inflammatory processes to ramp back up. So you don't necessarily need rapamycin to get that effect over the subsequent 3 months.
All the time, Right. That's similar with the FMD. In the FMD, the usage of the fasting mimicking diet. You do continue to see benefits from doing the cycle 3 months after being done.
And it makes it's very biologically plausible for how that might be working, right? And it's worth saying, because mTOR is a nutrient sensor, one of the things that fasting or caloric restriction does is turns down mTOR. So rapamycin is not equivalent to caloric restriction or fasting, but they're overlapping in terms of the physiological changes that they induce.
In caloric restriction, you're also turning down other
like AMPK,
of course, 100%.
And all of the other things.
All of these things interact in a network, though. So rapamycin does some of those things. I think of it as like overlapping but distinct. If you think of it as a Venn diagram of all the changes with each of those, there's going to be some that are in the middle, right? But there's going to be things that each of them do that are different.
Right.
Caloric restriction, fasting probably have many, many more changes than rapamycin does, because they're going to hit, so many different cellular processes. But there definitely is going to be that overlap.
And I feel like when I think about fasting and fasting mimicking, you're starting further upstream, whereas rapamycin is coming in at the mTOR level. So it's happening here and then downstream from there, right?
Yeah. Yes, and caloric restriction and fasting hit a bunch of other things that aren't touched by rapamycin.
Right.
And it's probably worth saying, turning down mTOR in the context of a nutrient replete state, right, where you're still bringing in normal amounts of calories, is probably going to have different effects than turning down mTOR in a calorically restricted or fasting state. So that's why I say they're distinct, right? They're different from each other.
I am curious. We're autophagy gals. We obviously in the FMD world.
Is that what they call you guys?
Yeah. We're the autophagy gals.
I don't know what that really means. If we're the autophagy gals, we're like constantly consuming waste.
I know. Just to make room for new things, better.
We're creating space for beautiful new things.
That was a silly joke.
It's a science joke.
I'm curious about. A lot of what we do, what we're set out to help people achieve, is this element of autophagy. I'm curious, in your world, I'm sure this is part of your research, do you find that rapamycin has a similar effect in accelerating the effect of autophagy in humans? Autophagy being cellular cleanup, rejuvenation.
Right. Great question. So again, we have to be clear what we know in animals versus what we know in humans. So it is absolutely the case that at the cellular level, inhibiting mTOR turns on autophagy. Like that's in fact one of the first things that was discovered about rapamycin and mTOR, that when you treat cells with rapamycin, autophagy gets boosted. And there's lots of evidence in animal models that treating animals with rapamycin increases autophagy across different tissues and organs. So that's clear. Less clear in humans is we don't have great biomarkers for measuring autophagy. And again, this is getting a little bit in the weeds, but autophagy, of course, it's got multiple steps to it, right? There's the process of, engulfing whatever is going to get degraded, then it's going to be transported to the lysosome where it gets degraded. So you can think of it like the recycling center, right? The recycling trucks have to go out, pick up the waste. So that's step one, engulfment. Bring it back to the recycling center. That's the lysosome. That's step two. And then actually the recycling has to happen, right? Melt it down, whatever you need to do. So you can think about autophagic flux, which is how much of the garbage that gets picked up, the recycled waste that gets picked up, actually gets recycled. That's the flux, how much goes through the whole system. Yeah. We don't have good biomarkers for measuring that.
LC32.
Well, that's a marker of one step, right? This is the process. That's what I mean. So you can measure markers of different steps, but you can get fooled. Because if you're measuring a marker of how much stuff gets to the recycling center, if the recycling machinery's broke, you'll think autophagy's turned up,
right?
But actually it's turned down because it's not actually getting recycled. So that's what I mean by the biomarkers for autophagy are not very good. Yeah. So you get fooled a lot. And we see this in the animal models sometimes in disease conditions. If you measure a marker of the recycling center, it's way up, but it's because the process of actually recycling the garbage is broken. So if you don't know what's going on, you'd think, oh, autophagy is increased. That causes this disease, but it's not. It's the fact that it's not productive autophagy.
Right. We got work to do, it sounds like.
So one of the things that rapamycin seems to do, and I'll say seems to because this is going to be a generalization and probably an overstatement, but there's data to suggest this is, in situations where that last step of autophagy or one of the steps is stuck, rapamycin, through mechanisms that aren't really understood, seems to kind of clear the system out. So I think of it as allowing for productive autophagy, or maybe even promoting productive autophagy.
That's a good little pair.
That is
then.
a very good. Yes.
Imagine you do them together.
Oh my gosh.
So I mean, all of this is to say autophagy is centrally important, probably, to many of the benefits that are seen with rapamycin in laboratory animals. Yeah. It's best established in C. elegans. It seems like turning down mTOR, turning down insulin signaling in these nematode worms, which can increase lifespan, that requires autophagy. And we know in worms, if you increase autophagy, that's enough to increase lifespan. So I call that necessary and sufficient. That hasn't really been demonstrated in mice yet, but it's likely that increasing productive autophagy contributes to many of the benefits of rapamycin.
Yes.
Okay, well, I feel like this is another natural progression to what can we safely say for rapamycin in humans? So
I will tell you my opinion, and then we can talk about what data actually backs it up. So I feel pretty confident in both dogs and humans that rapamycin can be used off-label safely. Like we know enough about the side effect profile, we know enough about the dosing where we can use it without risk of serious adverse events. It doesn't mean there's no side effects. Everything has side effects. Fasting has side effects. Supplements have everything has side effects. That means
a lot coming from you, Matt. Like truly, that's it. That's all I needed to hear.
Well, so if we want to talk about side effects, I people get upset with me for this sometimes, but I think this is actually a really useful analogy for people to think about. So side effect just means an effect that wasn't the reason that you're doing this intervention, right? If you had a pill that gave you all the benefits of exercise, you get all the benefits of exercise in one pill, and you tried to get that approved by FDA, you wouldn't even make it past phase 1 because of the side effects. If you think about all the side effects of exercise, pain, injury, sometimes sudden cardiac death.
Oh my God.
Right? You wouldn't even get past phase 1.
Right.
So it's just useful to reframe for everyone. Everything has side effects. And the real question is, do we understand the side effects? Do we understand how to use the intervention in a way to minimize the side effects? And are the benefits greater than the side effects? So it's all a cost-benefit analysis.
Right. And there's plenty of side effects that I'm totally willing to be okay with.
Yeah, sure.
Even I'll take lightheadedness or maybe even a little fatigue or, some of these little things.
Maybe.
Yeah. Like I'll take that if the benefit outweighs.
Right. And that's the other thing to appreciate is for most of these things in humans, we have different degrees of confidence in the benefits. The side effects are usually pretty easy to characterize. The efficacy, especially for something for longevity, is much harder to characterize. So it's a confidence thing. It's a probabilistic thing. Like, you're probably pretty confident that fasting has these benefits for you.
Yeah.
But it's not 100%. Other than, weight loss, that's pretty obvious, right? But outside of that, it's not 100% that you're going to live longer if you fast once a month, right? So you have to think about this in a probabilistic way and recognize, that there's
adjacent
evidence supporting
markers?
It, but
adjacent markers maybe is what I'm thinking.
There are biomarkers, yeah. So again, this is where I think that helps with the confidence piece. So if you see that the intervention you're using reduces inflammatory markers, reduces lipids, reduces fasting blood glucose, improves insulin sensitivity, you feel pretty good about that. Yeah. If it made those things go the other direction, you'd probably be like, maybe it's not exactly doing what I want it to do. Yeah.
And so are we seeing any of those other adjacent markers with rapamycin?
So this is where I think it's a combination of optimism and frustration that what we don't have. The frustration is that what we don't have are the large randomized placebo-controlled clinical trials with rapamycin. And the reason we don't have those is because rapamycin's been off patent for many, many years. There's no incentive for any company to go through the process of doing the large clinical trials for what would be called label expansion, meaning getting FDA to say, okay, now rapamycin is approved for, dilated cardiomyopathy, whatever that is, right? So there's no incentive for them to do that label expansion. And so nobody does the large clinical trials. So what we end up with are, many small, underpowered academic clinical trials generally. So what I can say from those trials is there is a positive signal, and this is where, it becomes an opinion. How much do you believe the trials? Maybe there's 5 people, but the efficacy signal was really good. Some people are going to be like, you can't learn anything from a study of 5 people. And other people are going to be like, well, I think that actually means something. So
indicator.
Yeah. So what I can say is there are a few places where I feel between cautiously optimistic and fairly sure that rapamycin, off-label use of rapamycin can have some benefits for select people. One of those is in the brain. So especially in people who are at high risk for dementia because they carry a variant of a gene called ApoE. So this is the ApoE4 variant. So there have been 2 studies now, tiny studies, like I'm not joking, 4 to 8 people, but using endpoints that are pretty interesting. So 2 studies now showing that within a few weeks of ApoE4 carriers taking rapamycin, you can see improvements in cerebral blood flow and improvements in brain volume. And those are things that are early indicators of onset of dementia in that population. And that matches dozens of studies in mice showing the same thing in both normally aging mice and mouse models of Alzheimer's disease. So when I see the same exact physiological changes measured using state-of-the-art methods, and they're reproduced from mice to humans, that starts to give me confidence. Okay, yeah, that's very likely real. Does that prove that rapamycin is going to protect ApoE4 carriers from getting Alzheimer's disease? Doesn't prove it, but certainly cerebral blood flow and brain volume are pretty good indicators of that disease progression, right?
Exciting.
So that's pretty interesting. There are 2 fairly large phase 2 trials from Joan Manick using a derivative of rapamycin. You can just think of it as the same drug. It doesn't really matter. It works exactly the same way, showing you can boost vaccine response in healthy elderly people. That also is backed up by mouse studies.
Wow.
So same thing.
This is so perfect because my follow-up question was to talk about the immunosuppression piece, right? Because I'm hearing you say immune support, but in the back of my brain, I keep hearing this dude that is very big in the longevity space who speaks about how he had his immune suppressed, immune health suppressed.
Yeah. So, I mean, rapamycin is used as an organ transplant drug. Yeah. It can suppress immune function at high enough doses. Right. It's not actually a potent immunosuppressant by itself. Even in organ transplant patients, it's always used in combination with other drugs that are true immunosuppressants. So I think of it more like an immune modulator, an immunomodulator. But yes, probably at high enough doses, it will increase risk for certain types of infection, most likely bacterial. So rapamycin is a little interesting in that it actually boosts antiviral gene expression, which may be where you get the protection for coronavirus, even though the vaccine was for influenza in those people who were treated with the drug. So there may be a difference between types of infections. But yes, at high enough doses, it will suppress the immune system. People have looked pretty hard to try to find immune suppression at the off-label doses. There just doesn't seem to be a signal there. Okay. So if there is a signal, it's small enough that it has never reached statistical significance. And there's reason to think, and you can explain the immune boosting component here. Right. So again, I talked about chronic inflammation. With age, in every mammal, we see a dramatic increase in what we call sterile inflammation or chronic inflammation. Sterile just means this is your immune system responding to something it shouldn't be responding to, right? It's not a bacteria, it's not a virus, it's usually self. Autoimmunity is part of this increase in chronic inflammation or sterile inflammation. Rapamycin's really good at blunting chronic sterile inflammation. One of the things so everybody says immune function declines with age. Right. That's half true. immune function also goes up with age. It's just your immune system responding to the wrong stuff.
Sure.
Mm-hmm.
So if you can blunt that chronic inflammation, that sort of resets the immune system and allows it to function the way it's supposed to. So that probably explains the improvement in vaccine response. It might also explain the signal that comes even from organ transplant patients for reductions in many types of cancer, because immune surveillance is a potent anti-cancer mechanism. So the honest answer is, off-label use of rapamycin, we don't know with 100% confidence whether it is an immune booster or an immune suppressant or both. The evidence we've got, I think, tilts towards improving immune function, at least many aspects of immune function. And I will just say, this is not a diagnosis. The individual who you are referring to, who shall remain nameless, stopped taking rapamycin, somehow knew that rapamycin, out of the 150 other things he was taking, was causing whatever it was that he thought it was causing, has since developed an autoimmune disease. I'll just leave it at that.
Well, that was what
The
she
big
was
news.
coughing over here.
Yeah.
Yes. Well,
And I will say there are dozens of published case reports and hundreds of other anecdotal reports for a variety of autoimmune disorders where rapamycin seems beneficial.
wow.
I was
that's
actually, that was going to be a
incredible.
follow-up question, because I was thinking,
Yes.
well, if
Let-
it's more of a modulator, then it would hypothetically be beneficial
Yes.
in those populations.
Yes.
I am taking a slight sidestep because I'm a dietitian, and we know you mentioned earlier about rapamycin is tapping into a mechanistic effect in the body, right? It's having a mechanistic effect, but food can too. So I'm curious what your thoughts are, because mTOR also, just for everybody, is triggered by protein intake amongst some other nutrients.
Yep.
What's your take on the excessive protein trends that are happening right now in the
It's a
world?
good question. I mean, again, this is one where I personally am still up in the air. Like, I don't know what optimal protein means. I mean, I know what suboptimal protein is.
Which is
if
bad for longevity also.
Absolutely. Yeah, absolutely. But I don't know what optimal protein is. I personally, for the last few years, have gravitated towards a higher protein diet. That seems to work pretty well for me, but I also eat a very clean diet most of the time. Maybe not for the last 2 weeks when I've been traveling, but no, really, most of the time I eat a very clean diet. And so I think, first of all, protein consumption, what's optimal, is going to be different if you're eating a high quality diet versus eating a bunch of processed foods, a bunch of simple sugars, and eating high protein. Certainly the risks that go along with the high protein diet, increased IGF-1, increased cancer risk, are going to be exacerbated if you're eating a low quality diet. So that's one thing I think that's worth putting on the table. The other is, I think as an individual, you need to evaluate for yourself. You know, one of the things many people report from higher protein is they have less appetite, they're not hungry all the time. So if that works for you, I think eating a high quality diet and high protein is fine. I don't think there's much risk associated with that. Having said that, you know, in the animal data, again, if we go back to mice, it's pretty clear that low protein is where you get the longevity benefits in mice. Whether that's true in people or not, again, I think we have to recognize it. When it comes to muscle mass and frailty and bone density, people are different from mice, and those are the things you would be concerned about with a low protein diet.
Right.
The other thing I'll say, there's some interesting research. I actually just did an interview with Crystal Hill, who's at University of Southern California here in LA, who studies low protein and FGF21, which is a hormone that responds to low protein. And so she was telling me about some studies that have come out in people, but when they study, you know, quote unquote, low protein in people, what they really mean is RDA. So there are...
Which is the recommended dietary allowance. Like, what most people are hitting no problemo.
Yeah, right. So when they take at least healthy men who are active down to the RDA, they don't lose muscle mass. And they seem to have actually a higher metabolic rate, meaning that to maintain weight, they actually have to eat more food. So context matters, I think, is what I would say about protein.
Well, it's very much about getting the right amount for you and not necessarily more than that. Protein isn't a magical macronutrient that's going to solve all your problems with eating more of it. It's about getting the sufficient amount for your specific health, your specific body in that unique time in your life. And
I do appreciate that you mentioned form. I mean, you're going more in terms of like whole diet approach, but also in terms of plant versus animal. I mean, having a healthy balance of the two, and preferably
100%.
more plant. I mean, those are all also going to help.
Yep. Yes, the way I think about it, and again, you may very well have a different opinion on this, is I would put diet quality as the first order thing.
Right.
Like, get that dialed in first.
Yeah,
Please. Yeah. I actually agree with that.
100% agree.
And I mean, again, there, you can get very granular, but at a high level, like, I actually, regardless of what you think about the upside down food pyramid and all that, like, I think eat real food is a good message, right?
Yes.
Like, lots of whole foods, lots of vegetables, and start there. Try to minimize the highly processed stuff. Yeah. And then you can worry about the protein.
Yeah.
And I'm not saying don't think about protein, but yeah, it's not going to make up for a low quality diet for sure. And more is not always better.
Yeah. Yeah. Well, and it's also, everybody is getting the RDA. I loved that comment, is that this low protein concept is actually them just getting the RDA.
Right.
That's so interesting.
Right.
It's not actually super low.
Although the RDA recently changed, right? So
yeah, it was a few years ago, I think, but yeah, they did move it up. Yeah,
to 1.2.
Yeah.
Which from 0.8, that's a big jump.
Yeah, that is a big jump.
Okay, I have a couple quick questions. First, I was looking, and it seemed like there may be some sex differences in the impact of rapamycin between men and women, and specifically potentially better for women.
Yeah, we want to know. Yeah. We want to know.
So let's start with the mouse data, because I think there's a lot of confusion there. Even people in the field who really should know better get this wrong all the time. So in mice, at the initial doses tested of rapamycin, females got a bigger lifespan extension than males. Mm. That seems to be a dose effect as opposed to rapamycin works better in females.
Okay.
So if you go up to higher doses, the males catch up, and you can actually hit a dose. We sort of did this accidentally in our 2016 study, where you actually go too far in the females, so you lose most of the lifespan benefit, but you get a bigger effect in males. So it's just a different dose response.
Okay. So we need less.
In mice. And there's directional evidence in people
immediately
supporting this, right? So there's one study that I think this is probably what you're thinking of, called the Pearl trial, where it was a distributed clinical trial. It was placebo controlled, where people got either placebo, I think it was 5 milligrams of rapamycin or 10 milligrams of rapamycin. It might have been 4 and 8, or it's either 4 and 8 or 5 and 10. They thought that was like a low dose and a high dose. Unfortunately, it turned out to be a much lower dose than they were shooting for, because they used what's called compounded rapamycin. So it was compounded by a compounding pharmacy without actually using an enteric coating on the pill. So you need this enteric coating because rapamycin is unstable at stomach pH. It has to get to the small intestine to get absorbed. So they were probably closer to 1.2 milligrams at the low dose and 2.5 milligrams at the high dose. Okay. So in that study, the overwhelming signal was, there's not much here. For all the things they looked at, really not much moved. The one thing that looks pretty real is in the women, and it was a year-long study, so it was a reasonable length of time. In the women who got the high dose of rapamycin, they had better body composition, in particular muscle mass. So more muscle mass at the end of the year than they had at the beginning of the year. So at least for muscle mass, that low dose of rapamycin in women, didn't see it in the men, seemed to improve lean mass and overall body composition.
Great.
This is particularly interesting, of course, because, talking about mTOR as a promoter of growth, if you go back to the bodybuilding literature 10, 20 years ago, and even still, everybody wants to turn up mTOR because you need to turn up mTOR to build muscle, right? So there was this concern that rapamycin would actually promote muscle loss and sarcopenia with aging. That's been dispelled in the animal models. It protects against muscle loss and aging in both mice and rats. But in people, it's still been a concern. Would people taking rapamycin off-label lose muscle? The answer seems pretty clearly no. And if anything, at that dose in women, it might actually help preserve muscle with aging.
That was what I was like, interesting.
Now, it's probably worth just talking briefly about this more recent clinical trial that came from Brad Stanfield, looking at rapamycin in response to exercise. Because again, I think this gets... It's confusing, right? So
is that the New Zealand?
Yes, Rapa-EX.
Yes. Yeah. Okay, cool.
So Brad's a physician in New Zealand. He's a friend of mine, and he's been wanting to test whether rapamycin could help with muscle function in the context of healthy older adults and exercise. That was the goal of the clinical trial. And so he raised money. He actually spent some of his own money, like mortgaged his house to pay for the clinical trial. He's an amazing guy.
That's
He's a
awesome,
super genuine,
let's go.
nice dude. Yeah. Unfortunately, and I told him this before the trial started, he didn't really have enough money to do what I would have done at least. So what the trial ended up being was 13 weeks, healthy older adults who were sedentary, putting them on an exercise regimen. Half of them got a placebo, half of them got rapamycin. I should know the dose. Age-related cognitive decline. I don't remember what the dose was. It's somewhere around 6 milligrams a week.
Okay.
Yeah.
Great.
And in that trial, what happened was, as you would expect, both groups improved. And the endpoints were kind of basic geriatric assessment. So this thing called a sit-stand test. How many times can you sit up and stand down in a fixed period of time? Grip strength, 6-minute walk. Okay. So both groups improved, but the rapamycin group didn't improve as much as the placebo group. So one interpretation would be rapamycin is bad for muscle function and blunts exercise. I think you have to realize, though, and what I had wanted Brad to do was then do another 13 weeks either as a crossover where the placebo group would get rapamycin, the rapamycin group would get placebo, or just at least have another 13 weeks without rapamycin. Because the way I think about this is if you take sedentary people and you put them on an exercise regimen, they're going to gain fast, right? These are the newbie gains, right? And this was a really well done trial. Like they put exercise bikes in the people's homes and, made sure they were doing their resistance training. So these people were really exercising. And they saw good gains. And that's a very anabolic process, right? You're in this anabolic state for 13 weeks where you're gaining a lot of function and muscle. It's not surprising that if you turn down mTOR even just a little bit, you're going to attenuate those gains. Again, remember, the rapamycin group improved. They just didn't improve as much.
Right.
So I think this doesn't really tell us anything about age-related muscle loss. And what I think would be interesting would be if you were able to follow those people longer, say as long as the Pearl trial, would the rapamycin group have not only caught up, but have done better? We just don't know, right?
And also maybe in other metrics, right? Like we're talking, in the world of side effect versus benefit, like, maybe they would have had some minor decrease in muscle gain, but they also had better immune health and they also had X, Y,
But my intuition is that there is a dose of rapamycin and a way to use it where you can actually improve body composition over the long run. I just don't think 13 weeks in a sedentary population that starts exercising, it's a different question that you're asking.
Well, it's also context. You're adding another, going from 0 to something is that we already know that it makes a huge difference in people already. So it's kind of like
and again, coming back to fasting, you would expect exactly the same thing with fasting, right? If people were doing an intermittent fasting regimen, they probably wouldn't gain as much muscle if they're in a hyperanabolic state like that.
Which is why we cycle that too.
We have. I know a lot of the questions that I still have are in the mailbag, so that is
that's
good.
Ideal.
But my final non-mailbag question is because I want to know more. I'm excited to know more, but obviously we need money to do these trials. And I'm curious if you're part of the X Prize or doing anything there to potentially.
Yeah, I'm not part of the X Prize. Obviously, I thought about putting a project in, but decided I had too many other things on my plate at that time.
Sounds about right.
There are a couple of things that are happening that are probably worth mentioning with rapamycin specifically. So I mentioned that it's been a challenge to get these large clinical trials we would all like to have. So recently. A friend of mine, his name is Ken Coit, funded a large clinical trial at the University of Arizona. It will enroll 725 people over a 3-year period, looking at metrics of immune function and muscle function and things like that. So I think that might be the first opportunity to get really high quality data over a long period of time on rapamycin. And again, these are going to be healthy elderly people. So I think it's 65 to 85 is the age group there. And I'm helping to advise on that trial. So that's good. Our rapamycin trial in dogs is ongoing. About half enrolled. It will be 580 dogs. So that's been refunded by NIH. So that will get done.
This is so great.
So that will give some information. And then ARPA-H has this program called Prosper, where there are several teams developing biomarkers for intrinsic capacity and then testing interventions against those biomarkers. And rapamycin is one of the interventions that's being tested there. So there are some reasons for optimism that we'll get a bit more data from a larger, longer term studies.
And having ARPA-H support is from what I understand, is especially meaningful because when they don't see opportunity, they cut it off right away.
Yeah.
They're like, now we're done.
Yep.
So
that's hard boundaries.
Yeah. No, it's great.
We're switching gears. We're going to our mailbag. These are questions we get from our community, our guests, and they can be for any of us. Although we will. I know we have
these
several.
Ones are a lot for you.
Yeah. Okay. So question number 1. Everyone in the longevity world seems to be taking rapamycin now. Should a healthy 45-year-old actually consider it, or is it too experimental? I guess we
So two things to say there. Not medical advice. Actually, three things to say. That's my disclaimer. Not medical advice, not veterinary advice. So first of all, the perception that everybody in the longevity field is taking rapamycin is just a myth.
I was going to say that. I would
say 5% of people, maybe, if that.
Yeah.
It's talked about a lot, but it is certainly not something that the majority of people are doing. So the question was, should a healthy 45-year-old take rapamycin? Again, there are many things that go into that, right? What's your tolerance? What's your risk-reward tolerance? What are you using it for? What does healthy mean? The way I think about rapamycin use off-label is for people who have high chronic inflammation, autoimmune tendencies, high risk of dementia, or early onset of dementia, there the risk-reward calculation changes. And so those are the people who I think are more likely to get a benefit from taking rapamycin. Again, my personal opinion is that the risk is pretty low, but that's my personal opinion. And the honest answer is we just don't have the large-scale, long-term data on off-label use to know exactly what the risk is.
Yeah. I like that answer.
I love that
I
answer.
like that answer.
I picked the next question. I'm jumping ahead because I'm excited about it. And actually, we should maybe just talk about your water bottle.
Can you see it?
For anybody who is not, I have to make
not
sure I'm
watching this video.
Proof that I am a longevity nerd.
Okay, tell us a little bit about this water bottle really quickly.
So that cool. Water bottle came from the Longevity Biotech Fellowship, and it has all of the molecules that have been shown to increase lifespan by the mouse interventions testing program, at least as of a couple of years ago. So it's got the structure of all of the longevity molecules.
We love it.
We love it. And it brings me to my next question, which is actually about metformin.
Yeah.
So my doctor won't prescribe metformin unless I'm diabetic, but I keep reading it might slow aging. Is the evidence actually there for healthy people?
No.
But
I will add some context. So metformin is a great diabetes drug. And there were a couple of reasons why people were very bullish on metformin as a longevity drug.
Right.
Some of this comes from mouse studies. The first mouse studies that tested metformin for lifespan were done by this scientist named Anisimov. He's a Russian scientist. He used short-lived strains that were prone to certain types of cancer. And in that context, metformin had an increase in lifespan. When that was repeated in longer-lived strains like the interventions testing program and other studies, that lifespan effect went away. So I would say even in mice, the evidence that metformin effectively targets the biology of aging is minimal. And I don't think metformin is an effective drug for slowing aging. Now, in humans, there was a lot of excitement about metformin from a study that was published probably, 5 or 10 years ago now, where they looked at mortality and they compared 3 groups. They compared diabetics not taking metformin, diabetics taking metformin, and non-diabetics, so healthy people not taking metformin. And so when you compare diabetics not taking metformin to those taking metformin, there's a big increase in lifespan, reduction in mortality. But that study also reported that diabetics taking metformin lived longer than non-diabetics not taking metformin. And so that got people really excited that maybe this is a longevity drug in people, along with some other evidence that it might have some benefits for certain types of age-related diseases. That evidence is mixed in my view. But unfortunately, it now seems clear, I think 2 or 3 studies have failed to reproduce that epidemiology where diabetics taking metformin lived longer than non-diabetics. And there's some indication that there was mistakes made in the way that analysis was done. So that doesn't seem to be true either in humans. And I think we've also learned there are maybe some side effects to metformin that we didn't appreciate as much previously when it was only being used for diabetics, such as blunting the response to exercise. And again, that seems pretty clear in both mice and humans. So, my thought is if you have diabetes, your doctor recommends metformin, take metformin. It's certainly not even in my top 20 for a potential longevity drug. And I think, this is where different people are going to have different opinions. I know Nir Barzilai is still very bullish on metformin, but I think most experts in the field have moved away from metformin. In fact, on my podcast, I keep plugging my podcast.
Yeah, it's a great podcast.
I interviewed Steve Ostad, who's like one of the longtime leaders in the field. I interviewed him and I did this game with him, which, you might want to incorporate this. I thought it was so much fun. I'm going to do it from now on. So Steve was actually involved with Nir in organizing the TAME trial. This is targeting aging with metformin. The idea was to do a clinical trial in people for multiple chronic diseases to get FDA to say, yeah, this is an appropriate way to test a longevity drug. And they got approval from FDA. They never could raise the funds to do TAME, so that still hasn't happened. But if people have heard of targeting aging with metformin, that's this clinical trial. So Steve was involved in designing it. And so I asked him, near the end of the podcast, I'm like, okay, so let's talk about TAME. And we walked through what TAME is. And I'm like, okay, I'm a billionaire. We'll just pretend I'm a billionaire. I'm willing to give you enough money to test one thing, rapamycin or metformin. And without even thinking, he's like, rapamycin.
Yeah.
Then I'm like, SGLT2 inhibitor or metformin? He's like, SGLT2 inhibitor. I'm like, GLP-1 agonist or metformin? He's like, GLP-1 agonist. I'm like, okay, so I think, we can see that the field has sort of shifted in terms of what people are most excited about. And I think most people in the field would align with that.
So what are your top three?
Those three, rapamycin, SGLT2, and GLP-1. And honestly, I'm known as like the rapamycin guy. Yeah. But if this was like, you have enough money to test one thing, you want to take your best shot on goal for a clinical trial, I don't know which of those three I'd pick. I think it's pretty close. The GLPs don't have as much evidence for longevity, that they actually target the biology of aging, but they clearly can hit multiple age-related conditions, and they're sort of a caloric restriction mimetic.
Right.
The SGLT2 inhibitors they're on this, they increase lifespan in mice, and they also seem to be hitting multiple age-related diseases in people. So, and for the GLPs and the SGLT2s, we've got a much better safety and efficacy understanding around dosing if you want to do a clinical trial in people. So I still think rapamycin is the best bet, but with the uncertainty that we don't really know what the optimal dose is in people, we don't really exactly know what the side effect profile looks like. So it's a tough call with those three.
Right.
We have time for one more.
Okay.
One more
pick.
question. I take about 8 longevity supplements a day. And honestly, we don't know what they are. And honestly have no idea if any of them work.
Yeah.
If you had to throw out all but one, which would survive?
Ooh, that's a good question. Creatine. But it's not a longevity supplement.
I think it is a longevity supplement because it supports with cognitive health and muscle protection, and those are both important things for longevity.
Let me frame the lens that I think through. So I agree with you. It depends on what you mean by longevity, right?
Right.
I think of something that slows biological aging. That's my first sort of classification. I'm not saying creatine doesn't. There's no evidence that it does.
Yeah.
But in terms of like something that it almost certainly isn't going to hurt you, where there's pretty good evidence for benefit across multiple domains, that seems like a safe bet.
Right.
And I will say, it's going to give you more benefit if you do resistance training. Everybody should do resistance training. Of course. So take creatine and do resistance training.
It's a 2-for-1.
What's the dosage you would suggest?
So I do 5 grams a day. I know lots of people are talking about 10, 15. I've read the literature. There are some cases where they give short-term 10 grams a day and you can see, improvements. But in all the papers I've seen where they compare that to longer term at 5 grams a day, the 5 gram a day catches up. So the idea that you have to take 10 grams in order for it to get to the brain, blah, blah, blah. I mean, maybe it's true, but I haven't seen any good evidence for that.
Let me throw in a couple caveats on this one because I have to.
Okay.
One, if you're doing creatine, consistency is just as important
100%.
as dosage.
Yep.
So it has to be
I've got
consistent.
5 grams creatine in here.
Yeah, I have 5 grams.
That's also true of any nutritional related supplemental thing. The consistency is huge. You're not going to make a difference with one dose of vitamin D or omega-3.
Right.
Well,
but especially with creatine, that's really
it builds. It builds.
Yeah, and actually for omega-3 and vitamin D too, it's worth mentioning. I mean, so those are 2 others that I take. So I only take like 5 things.
Yes.
Like I'm a supplement minimalist, but those are good because you can measure, and you should measure, and then you can supplement into what we think right now is the optimal range, recognizing that may change. I think a couple things I would say there. One is you have to be careful you don't take too much vitamin D. That's why you need to measure. And that's probably why many of the vitamin D trials have not shown a efficacy signal, because they didn't actually measure it. They just gave everybody the same amount, which is stupid. So measure and supplement yourself into the range that you want to be in.
And thank you for saying that, because that was going to be my final add-on, is that you, at the end of the day, it's based off of what you need.
Yeah, 100%.
I mean, creatine is a good one because pretty much everybody should be taking creatine, right? Almost everybody, But vitamin D and omega-3s, most people should be taking them if you are.
And vitamin D especially is quite variable, both in how much you're endogenously synthesizing, and also when you take a supplement, how much actually gets into your system. So, so both of those I think are worth flagging for that reason. The other thing I'll say is, don't get scared off. There was a recent study on fish oil, and it was sort of interpreted as it causes dementia. The study's fine for what it is, but it was not a great study It's one study among many.
Yeah.
Don't get scared off of omega. Get a high quality EPA, DHA supplement, and you'll be fine.
From small fish. Yes.
Agreed.
Oh, Matt. This is so great.
Do
you want to just continue on till lunch? Thank you so much for joining us. It is truly, I mean, you taught us so many things today.
Yeah,
we really appreciate it.
No, it's been a lot of fun.
And be sure to check your new podcast out.
Yep.
Longevity Science with Matt Kaeberlein. And
what else do our listeners need to know?
I guess what I would say is, again, going back to this signal to noise problem is just have a healthy dose of skepticism. There's lots of good stuff in the longevity field, but you need to approach it with a dose of skepticism.
There we have it. Matt Kaeberlein.
So good.
Thank you for joining us.
Thank you so much. Truly.
I'm ready for rapamycin.
I know.
I mean, within reason.
But
I think I'm sold.
Yeah. Are you? You're ready. You're gonna go call somebody up.
So I have a vested interest in its impact on autoimmune patients. Specifically, I work with a lot of autoimmune patients. Yeah. My sister being one of them, and I'm fascinated. I would love to try.
But yeah, so I think yes. But I've decided, as I mentioned in the episode, that I'm gonna cycle it. Yeah, because we just don't know, and I just feel good about being more cautious than.
Sure. And also, as he said, too much of anything is, I think too much of literally everything is probably a bad thing. But
exactly.
Matt, what a joy. He could literally tell me, give me his opinion. I would say, that's it.
For sure. But there are people
we're joking. We will always do our research. And he's a very well-respected, very well-read.
Yes.
So we thank you so much for being here, Matt. We're very grateful. If you enjoyed this episode, please like, subscribe, comment, review, share it with somebody that you love, especially, those who would love to geek out on some longevity science with us today. Thank you for being here with us.
Thank you for being here. We'll see you on the next one.